start from the current slide. And let me go over these announcements. I'll try to make them quickly because there's a bunch of them. I told you about the presidential scholarships at both UAB and University of Alabama, Tuscaloosa. The deadlines are today, okay? So if you know of anyone who, they have to be graduating this term. Not still got a few courses in the summer, graduating this term. So those are they. Okay. Now this one has the deadline of today. No, okay. The deadline is March 5th, but there's an event today, and this is Kenesha here. Okay. All right. NCAS stands for NASA Community College Aerospace Sciences, or something like that. Okay, Scholars, Aerospace Scholars Program. There's a little thing on the right above the map out there. Someone put that up. There is a fellowship summer opportunity available to you. If you want to participate, today there is a, let me find it, online information session. And that's today, March 1st, from 5 to 6 this evening. So if you're interested in this, go to that session. Now, it's pretty important you do because the deadline date is March 5th, which is Monday, okay? So if you are wanting to participate, it's a great program. Several students, I think, from Austin have done it before. Here's a flyer on it. Ever wonder how your STEM class content is applied to the real world? The NASA Community College Aerospace Scholars answers this question. You spend 5 weeks in an online course learning about NASA's mission and research. You build a relationship with similarly minded students. You apply for a 4-day on-site experience at a NASA center, which includes immersing yourself in NASA's unique facilities, culture, and diverse workplace. You attend briefings by NASA engineers and scientists prepared to participate in other competitive NASA projects, programs, and opportunities. Students pay only the $30 registration fee to attend the on-site experience. And not everybody will get to do that because it's somewhat limited, but if you do get chosen, that's the only cost to you. NASA helps students make a connection between STEM degree and career opportunities. It's a good program, okay? I've got the information here. You're welcome to look at it. Remember, the information session is this evening, 5 to 6, and you can get the information about how to tie into that. There's also a Talent Development and Innovation in Sciences summer internship program that's been, the application has been extended, deadline till tomorrow, okay? This is through the Quality Education for Minorities, who works with National Science Foundation. So if you're interested in it, you better get moving on it today. Here's a little bit of information about it. It's the Talent Development and Innovation in Sciences, TDIS, summer internship program, 10-week paid internship, including housing for the interns. You don't have to supply your own housing. They will supply it for you. In Washington, D.C., conducting research projects with the National Science Foundation. See, I said they're connected. QEM, TDIS interns will also be engaged in a variety of professional development activities and can receive additional support from QEM to attend conferences, workshops, and trainings throughout the academic year next year, okay? So it's a great opportunity, but you need to get moving on it because the deadline is tomorrow. And there's a couple of testimonials here if you want to read those as well. Now, this is on the other side of things. There is a company called First Call Quality Services out of Indianapolis, Indiana. They will be here at the One Stop Career Center that's just next door here at the Millsap building. and they'll be taking applications for the job fair. Here's the jobs they have available. Quality inspectors at $11 an hour. Team leaders, $13.50 an hour. When will this be? Tuesday, this coming Tuesday, March the 6th, just next door at the One Stop Career Center. That's just outside the loop that goes around the building. It'll be from 9 till 1. They will be there and speaking with you. Benefits are available. It's not just a hourly job. You don't get benefits. Benefits are available. Applicants must have a clear background check, driver's license, high school diploma or GED, and it's helpful but not necessary, automotive manufacturing experience preferred. Okay? You can contact Ms. Brenda Thomas or Dorothy Henry over in the One Stop Center in the Millsap building. So that's coming up Tuesday. Get your stuff ready for that. Ms. Nyla Gerasi is our math team coach, and she's always looking for more students to participate in this. Fun time, helps you in your math courses. It's a great opportunity. They meet they meet Fridays at noon on the Birmingham West Campus in the Science Building C100. But not tomorrow. Ms. Gerasi will be at the same meeting I'll be at in Jasper, so she won't be there tomorrow. But they also meet every Monday afternoon at 3 o'clock. Same place, C100, Birmingham West Campus. Most Fridays she'll be there, but not this Friday. Told you before about the tutoring opportunities, either to receive tutoring or you're at a high enough level you could probably do some tutoring for them, because I know some of you have pretty good grades in your math classes, so consider the possibility. There's both the Space Center downstairs and student support services upstairs here, same level we are. On the Birmingham campus is STEM Lab and student support services, where I don't know if they have peer tutors, but I know they have tutoring there, and then they have a Space Center as well. All right, that's over with. Normally, after my 10:45 class, I have office hours for the rest of the afternoon. I have some office hours today, but not very many. After 10:45, I need to eat lunch as soon as I can, and then I go over to the Ethel Hall building and meet with the dean, because we're working on fall schedule, and then that will move into a meeting that's supposed to be from 2 to 5. I've got to leave the meeting at 4 so I can drive to Jasper, because I'm supposed to be there between 5:30 and 6. So once my 10:45 class is over, except for the time I'm in the office eating lunch, I will be either in Ethel Hall, meeting with the dean, at a meeting, or driving to Jasper. And by the way, I will not be on either campus tomorrow. I will be in Jasper. Okay? And I think I've asked it before, any of you graduating this term? Okay, you are. Okay. You know about the graduation meetings.
Can you give them to me again?
I'm sorry?
Can you give me the days?
Okay. They start next week, Monday, at 6 in the evening on the Birmingham West Campus in the ACAT building. Tuesday here on this campus at 1:30. And that'll be over here in Ethel Hall Auditorium. You know where that is? Okay. And then Wednesday, Birmingham West Campus again, the ACAT building at 1:30 again. So Monday evening, Birmingham, Tuesday afternoon here, and Wednesday afternoon there. 6 o'clock in the evening, 1:30 in the afternoon.
Thank you.
All right. And if you know of anyone who's graduating, please get that information out to them. And Taylor is here. Okay, has anyone else come in since I called roll? Okay, yeah, I saw you, Monica. I was going to mark you. And Jasmine decided to make it today. That's so nice. Okay. All right. And anyone else come in since I called roll? Okay, I think I got you all. All right, sorry the announcements took so long. Hopefully there won't be as many next week. Okay, Any questions on anything, school related, those announcement related, or math related, or Melva related? Oh, no, she's just here. Okay. Okay, Melva's here. Okay. Not? Okay. All right, where we left off last time was on page 87. We're in section 1.9, the last section in this chapter we're going to cover, meaning it's time for the test coming up real soon. And we're starting to do example 5, and here is example 5. This is the graph of this function, f of x is equal to x cubed minus 1. Now, hopefully you recognize that's the correct graph. Because if you did the graph of f of x equal x cubed, that was one of our parent functions, remember? And that would have started here, gone through the origin, and gone up here. Okay? That kind of stuff. Well, this subtracts 1 from that, subtracting from the function, so it drops at 1 point, 1 unit. So it's down here. So that's where it crosses and goes up from there. This minus 1 goes down to minus 1 minus 2. 0, 0 goes down to 0 minus 1. And 1, 1 goes down to 1, 0. Okay? So that's the graph of the function. Now, don't worry about the little red dot yet. Okay? But looking at the function, we can see that no horizontal line crosses that function more than once. That's what the red dotted line is, just a representative that none of them. The closest you get is right here where it sort of makes its bend. But if you check that, only 0 is at minus 1. Anything past 0 is just past minus 1. Anything before less than 0 is just less than minus 1. So yeah, its horizontal line only crosses once. What does that tell you about this function? One-to-one function. Very good. You remember. Okay? Because the horizontal line intersects the graph at more than one point, f is a one-to-one function. Now, if f is a one-to-one function, what else does that tell you? It does have an inverse, okay? It does have an inverse function, okay? Now, that's the A part of this. And by the way, if you want more insight in this, it almost is it 8 o'clock at night? Look at this. It's getting bad. Yeah, that's what it looks like. What's that? A maximum? Did someone leave a window open? Oh, lights on? Huh? Oh, really? Okay. Yeah. 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 And I'm going to Jasper, and it's supposed to be worse in northern Alabama. So, yeah. I'm looking forward to driving in that. What's that? Yeah. Yeah. Well, it's yeah. I think it's manageable, you know. Okay. So, by the way, what I was going to say about example 1, it says, see LarsonPrecalculus.com for an interactive version of this type of an example. So you actually have, let's see, to Darius here. If I can find you. There you are. And Brianna. I'm finding you. There you are. Okay. All right. So this is the A part. Okay? The A part says the graph of this function is shown here. No horizontal line intersects. It does have an inverse function. Okay? Now, here is the B part. What can you tell me about that function? Nice, pretty parabola. It is a function. Passes the vertical line test. It's a function. It's not a one-to-one function. It's not a one-to-one function. Why not? Horizontal line test fails. Okay? Now, how could you make that a one-to-one function? Hint, restrict the domain. If you only cover negative infinity to 0, that's 1-to-1. If you only cover 0 to positive infinity, that's 1-to-1. But the function with no restrictions, not a 1-to-1 function. What else does that tell you? Besides that it's raining. Yeah. What else does that tell you? Aren't you glad you got here early? Okay, or on time? Okay. Tells you this function on this domain does not have an inverse. Have an inverse, it has to be a 1-to-1 function, or restricted to a 1-to-1 function. Okay? Because it's possible to find a horizontal line that intersects the graph at more than one point. There's one of them, but there's tons of them. F is not 1-to-1, does not have an inverse. Very good. There's a checkpoint there too, that again, at larsonprecalculus.com, you can see audio video solution. Every example pretty much has a checkpoint. But some of the examples themselves you find at larsonprecalculus.com. All right, so now we're going to get down to what we've been looking forward to, finding inverse functions algebraically. Remember early on we just sort of guessed at it and said, yeah, this will work, no, that one doesn't work, you know, and stuff. Now we're going to see how to find them algebraically. Okay? For relatively simple functions, such as the one we did earlier, example 1, you can find the inverse function by inspection. Okay? Most of the time. Okay? For more complicated functions, however, it's best to use the following guidelines. Now, they say the key step to these guidelines is step 3. I don't necessarily number mine the same way they do, but it's the step that interchanges the roles of x and y. Now remember, that's what makes it an inverse function. You flip them, okay? If it's AB on this graph, it's going to be BA on that graph, okay? You're flipping x and y. That step corresponds to the fact that the inverse functions have ordered pairs with coordinates reversed, okay? So, here are the guidelines. Now, I'll do slightly different things with this, but here's what it says. Use a horizontal line test to decide whether f has an inverse function or not. What does that entail? Graphing the function, okay? Sometimes I don't want to graph the function. Sometimes I want to think through it rather than having to plot all the points and make sure I don't miss any that may have a little squiggle in there or something like that. But either mentally or physically, you got to make sure it is a 1-to-1. If it's not 1-to-1, don't bother trying to find the inverse. It doesn't have one. So you've got to do something to decide whether it has an inverse function or not. Horizontal line test is one way. Okay, now, you got the function f of x is equal to blah, 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 okay? You got blah, 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 okay. Now, next thing you do, what we've been doing from day 1, in the equation for f of x, what do we replace it with? What is f of x? Y. Take out the f of x, put in a y. Okay? Now here's what they suggest. And I would put this as 2 steps. Okay? Because it seems like 2 steps to me. First thing you do, number 2, you change it. F of x, made it a y. And then the first part of it, 3, you interchange x and y. What was the x? You put the y. What was the y? You put the x. Okay? Now remember you had it, f of x is equal to all this stuff with x's in it. Okay? And then you made this y, and then you made that x, and all those were y's, right? Everything over there had y's in it. Well, what do you do next? You solve for the y. So you've got to get all that other stuff over here with the x, solve for y. Isolate the y, okay? That, to me, should be its own step. 4 would be isolate the y, solve for y. Then, once you have solved for it, replace y with f inverse. Here, you replace f with y. Now you replace, when you exchange them, replace that with f inverse. Okay? Now, that's going to take some effort. But then once you got it, you've got to verify that f and that f inverse are indeed inverse functions of each other. How do you do that? We did it last time. I know it was 2 days ago, a long time. How do we do it? Okay. You do f of f inverse, and what did it better come out being? X. And if you do f inverse of f, what did it better come out being? X. If either one of those doesn't come out just a plain X, they're not inverse functions of each other. Okay? So this verification step, a little tedious, but it really is necessary to do. Okay? So, you may not remember all the steps, but we'll walk through them. Find the inverse function of that. Okay? The first step was do the horizontal line test, right? Which means graphing it, right? I'm going to do it slightly differently, if it's okay with you. Okay? I'm going to rewrite this ever so slightly, and I want you to make sure that you understand what I'm doing, and hopefully you'll see why I'm doing it. I'm going to rewrite this as 5 over 2 minus 3x over 2. Is that okay? I just took that denominator and put each of the numerators over that denominator. Legal move in most states, right? Okay. Now, I don't have to do this, but I'm going to do it just to make it a little more familiar to you. I'm going to swap the terms here and make that minus. I'm going to slightly rewrite the first one. 3 halves x plus 5 halves. Are you okay with that? Okay, that's a legitimate move, right? What's that a function? What kind of function is that? Hint. What is the exponent of your variable? The exponent of the variable. One! All right, clever. You saw it. Okay. Now, what does it mean if your variable only has an exponent of 1? What kind of function is it? Say again? I thought linear? Did I hear linear? Way to go. It is a linear function. Now, what can you tell me about that linear function? Two things are pretty obvious. I hope they're obvious. You've done them for probably several years now. That would be y is equal to minus 3 halves x plus 5 halves. What kind of form is that? Linear function. Huh? Slope-intercept form. Very good. So what does that tell you? Really obvious question. Which is which? Yes, you know. That's the y-intercept. Okay, we're not really all that interested in that now. And this is the slope. And it's going to be a straight line. Now, what can you tell me about the slope? It's a negative, meaning it's going downhill. And 3 halves is a little bit greater than 1. Okay, the magnitude is greater than 1. So that's a straight line going like this. Now, I haven't graphed it, have I? But if that's a straight line going like that, picture horizontal lines. Yeah, only going across once. That doesn't curve back up on itself or anything else. That is going to be a one-to-one function. And once we got it in this form, it's really easy to graph, and you can show that. You start with your y-intercept, and then you do your slope from there. Okay? But I don't really want to do all that. The book will do it. We'll see it in a minute. So we've done the first step. It is a one-to-one function. So it does have an inverse. Okay. Now we can go back to the original form. What was the... Webster, got it, Jayla. Okay. Anyone else come in since I called roll? Okay. What was the next step? Once you verified it's one-to-one, we know it does have an inverse. What's the first step to find that inverse? Pretty simple one, what we've done from the beginning. Yes, instead of f of x, we put y. Y is equal to 5 minus 3x over 2. We can go back to that form. What's the next step? getting sore up here. Interchange the x and the y. Very good. So what will I write down? X is equal to 5 minus 3y over 2. Got it. Now what's the next step? In the book, that's part of the same step, but I think it's a next step type thing. Solve for y. This is what we want to solve for now. So we got to get everything else. Solve for means isolate. Get it by itself. We want a naked y there. So what's the next thing we're going to do? Yes. First thing, the most remote thing from this y is that 2. Let's get rid of it. We'll multiply both sides of the equation by 2. Okay, that's legal. And there goes the 2's. All right. If you want me to, I'll write this down again. In fact, I'm going to change the order. I don't have to, but it's just, at some point I've got to. You don't have to, but it just makes it easier. So I'm going to change the order of this and say 5 minus 3y is equal to 2x. Okay? And what are we going to do? Solve for y. So what do you do? Subtract 5 from both sides. And what does that give us? Negative 3y is equal to 2x minus 5. Now what? Divide by negative 3. Both sides of the equation by negative 3. Okay? And those go out, and we have y is equal to negative 2/3 x plus 5/3. Or, if we want to make it look more like our original one, I'm going to, again, reverse the order of those and do 5 minus 2x over 3. Okay? You see that? Your denominator's 3. So put this common denominator, put both of them under 3. And then I'm going to lead off with the plus, like we did up here, minus 2x. Okay? Now, I'm not sure that any of us, I'm pretty sure I would have said by inspection, oh, that's going to be the inverse of that. We don't know that it is, but that's what it looks like for now. Okay? 2 steps ago, what's the next step? Okay, yeah. Replace your y with f inverse. And I'll do 5 minus 2x over 3. Okay? Now, the big step. That's what we think the inverse is. But we need to verify. And how do we verify? This was on Tuesday. I know it's a long, long time ago, but how do we verify? Now, before I do anything else, does everybody have this? Can I erase it? Because it's going to take more room than I've got on the board left. So what I want to do is erase everything except what f is and what f inverse is. All right, to erase? If you're through writing, I'll do that. Okay, now unfortunately it's going to take a while. There's my f. Okay. All those fun little steps we did, for some reason that's not erased. Oh, that's a period, that's part of the slide. And here's my f inverse. Probably should move it somewhere, but I'll leave it there. And you tell me how we go about verifying. All that erasing time was just to give you time to think it through. How do we verify? How can we tell if one function is an inverse of the other? What did Beethoven do? Oh, y'all forgot already. Composed music. So what do we do here? Do the composition of these two functions. It must be raining outside and everybody's still really tired. Okay, makes you sleepy, doesn't it? Okay. So what we're going to do, someone tell me what to write. Help me, somebody. Looking for what? Not numbers. It's f of f inverse. We're going to plug in functions is what we're going to plug in. Okay? Now, what do we plug in first? The outer or the inner? You tell me. The inner, of course. So this is going to be f, don't mess with that yet, of f inverse. Well, there's f inverse. That's 5 minus 2x over 3. Okay? Now, what does the f function tell you to do with that? Okay, so what we're going to do, the f tells you start with the number 5. I think I'm going to write it here. It's real close to that. 5 minus the number 3. But then instead of x, this is your x here, that's what we plug in instead of x. So we're going to plug in there 5 minus 2x over 3. And then divide that thing by 2. So you see what we did with x here, we do with this thing here. 5 minus 3, instead of x, you put this thing in, divided by 2. Make sense? All right, now we've got a little bit of algebra to do. What's the first thing you notice you can do in that expression? What happens? Okay, the 3's divide away. 3 over 3 is 1, right? So that gives us 5 minus, open parentheses, 5 minus 2x over 2. And then what would you do? Yeah, let's distribute that minus sign inside the parentheses. Be 5 what? Minus 5 plus 2x over 2. All right? And what do you notice happens there? 5 minus 5 adds to 0. And then what do you notice? The 2 over 2 divides to 1. And that leaves us x. Ding, 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 ding. That's exactly what we want it to be. But are we absolutely certain that's that these are inverses? There's one more thing we ought to do. Compose them the other way. Okay? So that would then be f inverse of f of x. Okay? And what do we plug in first? Do you want me to do this in a different color, or would you rather keep it the same? Different color. Okay, you pick a color. Orange. Okay, is that what you said? Okay, must be an Auburn fan. Okay, no, I didn't. I'm just kidding. Okay, so what do we plug in first? The inner or the outer? The inner. So that's going to be f inverse. Leave that alone, and we'll put f of x in its place. And what is that? 5 minus 3x over 2. Okay? Now we're going to operate on that strange entity with the f inverse. Well, there's f inverse down here. Okay? So what f inverse says to do is start with the number 5 and then subtract from that 2 times what's in the parentheses, right? Okay, and what's in parentheses up there? Say again? Yeah, 5 minus 3x over 2. And then divide that whole thing by 3. Okay? And what happens here? The 2 over 2 is 1. Okay? So you're left with 5 minus 3x over 3. And what do you do next? Distribute the negative sign, and that gives you 5 minus 5 plus 3x over 3. That looks pretty familiar, doesn't it? 5 minus 5 is 0. 3 over 3 is 1. X. Ding, 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 ding. It works. It works. Now, one thing we didn't do, and we probably should have, but it really didn't matter. But actually, we really did do it back on that when we showed that was a straight line. That's what's the domain of that straight line? Values for x's? All real numbers. Okay? It's a polynomial function. This one turned out being a polynomial function too, so its domain is also all real numbers. Okay? So, we don't need to worry about restricting domains anywhere. We got it. Does that make sense? Okay? Want me to erase this so we'll see how the book did it? Okay. All right. There's our function. They started with the graph. Only that's not the graph. Okay? That's a different function. Okay. This function is a straight line. I wasn't paying attention to the book. Sure enough, the one in our book, example 6, is a different function. So we'll have to just take my word for it. We did the other one right. They just don't have the right function in here. All right, so let's start over, okay, and do the function that's supposed to be there. Okay, let me go back to dark color. Okay. And let's get the right function in there. Sorry, I wasn't paying attention. 5 minus x over 3x plus 2. Okay. Now, does anyone remember how we graph that kind of function? Or maybe we haven't had it. No, yeah, I guess we have had it, have we? That's going to be in 2.6. So I'll give you a little heads up in how to graph this. Okay? First thing I'm going to do is kind of do what I did before. I'm going to rearrange that numerator and make it minus x plus 5 over 3x plus 2. Okay? Now here are some key points to graphing a function like this. Pick something easy. What's the easiest x you can put in there? 0. I love it. What's that going to give you? If you plot x for 0, that's going to give you a okay? When x is 0. Where is x equals 0 on this graph? Where? Where is x equals 0? I hear someone saying something, but I can't make it out. Where is x equals 0? Is it this way? No, that's positive. Is it this way? No. Where is it 0? In the middle, which is the y-axis. Everywhere on the y-axis, x is equal to 0. So when you plug x equals 0 in here, what are you going to get? The y, the quarterback threw the ball to the receiver, set in front. I never could do this. I intercepted it. Yes, exactly. Where the y-axis intercepts the function. Okay? That's going to be the y-intercept. And what would that be when x equals 0? 5 over 2. That's 2.5. So here we have the first point on the graph. Okay? Now, with that in mind, what's another pretty easy point to do? And when you're graphing this, think of this as, what is f of x? Y. So there we say x equals 0. What happens if we set y equals 0? If y is equal to 0 and it's equal to that thing, what's going to have to be true? How can you make that thing equal 0? Now, something over something. How do you make that equal 0? It's the top something. It has to be 0, right? The numerator has to be 0. That's the only way y could be 0. So what makes that numerator 0? What is 5? X equals 5, right? Okay? Now, let's back off a moment here. Where is y 0 on this graph? The x-axis. So what are we going to have there? the x-intercept, exactly. And that's going to be at x equal 5. 1, 2, 3, 4, 5. There's another point on there. Okay. So there we have two fairly easy points, the x-intercepts. The x-intercept and the y-intercept. Okay? Now there's two more things we can do fairly easily. Now that's all stuff you had before. Plug in x equals 0, you get the y-intercept. Y equals 0, you get the x-intercept. Okay? Now this is going to be sort of new for you. Okay, I think. What can you never do? Ever in mathematics? There's several things you can't ever do, but one thing you can never do has to do with this horizontal line here. What's second? You cannot have 0 in the denominator. Okay? And what would make that denominator 0? What value of x? And there's a real easy way to do it mathematically. You just said the denominator can't be 0. The denominator is 3x plus 2, and you said that cannot equal 0. Solve that inequality. How would you do that? Subtract 2 from both sides, and that gives you 3x is not equal to negative 2. And then what? Divide by 3. Divide by 3. X is not equal to negative 2/3. Okay? Where is x equal to negative 2/3? That would be between 0 and negative 1, right? So right there, approximately, I don't have my scale too well, but right there, oh, I'm going to put this in red. This is called a vertical asymptote. Because that right there, x cannot equal that value. That means it can't touch it, it can't cross it, it can't go there. Okay? So that's called a vertical asymptote. Now, we haven't done this yet, but I'm going to tell you how to do it. We also have something called a horizontal asymptote. We'll get to this in 2.6. That's why I don't like they gave you this problem here, but it's okay. To get a horizontal asymptote, you look at the ratio of the leading terms, and that's why I rewrote this. The ratio of the leading terms. What's the ratio of those leading terms?
X.
Say again?
Is it x?
Well, the x's divide out. X over x is 1.
3.
It is what? Negative 1/3. Right? See, this is a sort of a messy problem. The horizontal asymptote is negative 1/3. Y is equal to negative 1/3. Okay? So negative 1/3 is where? Down here beneath 0, below 0, 1/3 down. So it's going to be somewhere about right there. So I'm going to put my horizontal asymptote in there. Now, there's a little bit of a difference between a horizontal and a vertical asymptote. Vertical asymptote, it can't touch it. Horizontal asymptote, all it's telling you is where this function is going in the long term. Okay? It's because in the long run, it's long Lewis, not that. In the long run, the x's get very, very large, but they're the same values here. It doesn't really matter what this is. These are going to dominate. That's why we look at ratio of leading term, and that came out being negative 1/3. So that's where the x is going long term. Well, what that tells you here, these 2 points here, let me get my color back, will be approaching the y-intercept here, coming down, going through the y-intercept, and going through the x-intercept, and approaching the horizontal asymptote. That's where it's going there. Now, what we don't know is where it's going on this side. So here we just have to plug in a value. And I'd say the easiest one to plug in would probably be -1. Because this accounts for everything to the right of the vertical asymptote. Can't ever be in the vertical asymptote. Can't even touch the vertical asymptote. Certainly can't cross it. So let's do something on this side. -1. So all we do is plug in a -1. Okay? And what is f of -1? Tell me. Say again? Help me.
Plug in negative 1 was x.
For the x's, yeah.
So negative times x.
Okay, yeah, I'm going to do this one. Yeah, 5 minus a minus 1 over 3 times negative 1 plus 2. And what's 5 minus a minus 1, huh?
5 plus 1.
5 plus 1, which is?
6.
Okay.
Then negative 3 plus 2.
That'd be negative 3 plus 2, which is?
Negative 1.
-1. So that's going to be a negative 6. 1, 2, 3, 4, 5, 6. Somewhere down here is going to be that one. Okay? Now, it sure enough looks like to me that this has got to be approaching here, approaching negative infinity here. And then we could do another point if you wanted to, but somewhere up here it's got to do doing that. And that's exactly what that, pretty close to what that function looks like. Okay? Now, why did we have to do all that? To see if it's a one-to-one function. Okay? Except for x equal negative 2/3, this is strictly decreasing. That's strictly decreasing. Yeah, that's a one-to-one function, except, of course, x can't equal negative 2/3. Okay? Horizontal line test does fine everywhere. I know up here it looks like it might miss, but it doesn't, because that's still slightly decreasing going that way, decreasing going that way. So it never hits that value more than once. Okay? Awfully close, but not there. So all that was just to establish it is a one-to-one function. Shame on them for making us to go through all that just to get step 1. Okay? But we've done it now. So can I erase all this? Okay. So let's erase all this. Well, I don't want to erase it all, but it's going to be easier to rewrite it. Okay. Oh, I've got to get my function back in there. It's 5 minus x over 3x plus 2. Okay. So we've established it's one-to-one. What's next? What's next? Second? Have we got the inverse yet? No. We got to find the inverse. Very good. Okay. And how do we do that? Step 1. We verified it's one-to-one. Got that. So we know it has an inverse. Well, what's the next step to find the inverse? Real easy one. I said it from day 1. What's f of x? Y. Make that y. So we're going to rewrite this and make it y. Okay? Now what's the next step? Say again? Interchange the x's and the y. So what will that make it? 5 minus y over 3y plus 2 is equal to x. Yeah, that's what it is. Now, they counted the second part of that step. I counted a whole new step. What do we do next? Solve for y. Okay? That's going to be a bit more doing. What's the messiest thing about that expression right there? That equation? I know you love your fractions, but you have a denominator, don't you? How can we get rid of that denominator? Multiply both sides of the equation by that denominator. Okay? So this will be 3y plus 2, and this will be times 3y plus 2. As long as you do it to both sides, it's legal, right? Okay? Now, of course, y can't be negative 2/3, because that would make your denominator 0. Let's just say up front, y is not equal to negative 2/3. Any other value, it'll be fine. Okay? So let's go from there. Here, that disappears. And what do we have now? 5 minus y is equal to 3xy plus 2x. Yeah, I think we had to do that. Okay? And what's our goal here? solve for y. Isolate the y. So that means all the terms with y's on them we want on one side, and all the terms without y on them we want on the other side. Okay, we have two terms here, two terms there. And on each side you have one term with a y and one term without. So what I think I want to do is move this one over there and take the 2x and bring it here. Now I'm regretting I rearranged my order, so let's do it. So what we're going to do is add y to both sides and also subtract 2x from both sides. It's all right for me to do that like that. It's rather strange looking, but does it work? Or would you rather do it one step at a time? Say again? It works. Okay. So what do we have here? That goes away, those goes away. So what do we have on the left-hand side now? 5 minus 2x, don't we? 5 minus 2x. And on the right-hand side? 3xy plus y. Right? Now, what's our goal? Get y by itself. Well, over here, that's all your y's are here. No non-y's are here. So now you can factor the y out. Now I'm going to flip sides again, if that's okay. Factor out the y, and what do you have left on the right-hand side over here? 3x plus 1 is equal to, now I'm moving the left side to the right side, 5 minus 2x. Okay? Now, one last step to solve for y. Isolate the y. So what can we do here? Divide by 3x plus 1. 3x plus 1. And that's CJ here, right? I know you're in here. All right. Okay, and there we have y. Y is equal to 5 minus 2x over 3x plus 1. Okay? Now, I don't think that looking at this, I ever would have guessed that's going to be the inverse of it. You have to use these things. Simple things, yeah. 4x is going to be x over 4. This is not that simple. Okay? Now, there's one last step before we do our verification. What's that? It's kind of reverse of what we did going from here to here. What does this y become? F inverse. Okay. So this becomes my F inverse. Or at least that's what I think it is. Okay? Now, what do we have to do? Verify. Okay? So, oh, I didn't mean to erase that one. Okay. But I'm going to get rid of this because I think I'm going to need the whole board here. And you tell me how to verify while I'm erasing. Tell me what I got to do. There's actually 2 steps to it. What's one of those steps? Yes, you do f of f inverse, okay? And what do you plug in first? F of f inverse is that one up there. 5 minus 2x over 3x plus 1. Now, what does the f function tell you to do? There's the f function. Start with the number 5 and subtract from that what's in your parentheses, which is a mess, okay? That would be 5 minus 2x over 3x plus 1, okay? And then you divide that by the f function tells you to divide that by 3 times the x, which is what's inside your parentheses, which is, again, that mess. that would be 5 minus 2x over 3x plus 1. Okay? And then finally, we add 2 to that. Does everybody see that's what the F function tells you to do with this? You start with 5, subtract from that this thing, divide all that by 3 times this thing, and then add 2 to it. Right? Now, that is what some text calls a complex fraction. I don't like that terminology. I just call it a complicated fraction, because you got numerator and denominators in the numerator and denominators, okay? That's what makes it complicated. Now, what's the best way to uncomplicate that? Okay? You could, but I think it's probably easier to wait on that for just a second. Here's what I suggest. What is complicated about that? What was complicated before? Denominators. So find your least common denominator in both your numerator and the denominator. Well, the only denominator in either one of them is just 3x plus 1, right? So how do we get rid of the denominator? Multiply. So what we're going to do is multiply this whole thing, both terms up here, by 3x plus 1. Multiply this one by 3x plus 1. Multiply this one by 3x plus 1. And multiply this by 3x plus 1. Multiply everything, numerator and denominator, by 3x plus 1. All right. What does that make this? Now, here's your distributing. This first term here, what does it become? Usually you write it on the other side, but I didn't have room. What does that become? A little louder. 15x plus 5, okay, minus, and what happens here? That denominator goes away. That's why I multiplied by it. And what we have left is a minus quantity, 5 minus 2x. And put that parentheses in there, okay? What happens in the denominator? The 3x plus 1 go away, because that's what we multiply. And that gives us 3 times 5, 15, not x, 15, minus 6x plus, did I hear a 6x? Plus 2, right? All right. Now we need to clear that, distribute the minus sign across the parentheses. That'll be a 15x plus 5. And when you distribute the minus sign, what does that give you? A little louder? Minus 5 plus 2x, okay? And then the denominator, we can just combine like terms. And what happens there? Is what? The minus 6x plus 6x adds to 0, and what does that leave us with in the denominator? Which is 17, right? Okay. Now let's combine like terms in the numerator, and what do you get? 17x over 17, which is x. Ding, ding, ding. Okay. We got what we wanted there. And I'm really afraid I'm going to have to erase this to do the other verification, because I don't have room to write it, okay? So you got, it worked one way, so what's the other way we have to do it? I'm just, all right. You be thinking of that while I'm erasing. Are we out of time? No, not yet. Okay. We've got time. Okay. What is the next step? I want to say the final step. Do F inverse of F. Perfect. Okay. So let's do this. F inverse of F of X. What do we plug in first? The f. So f inverse of, and what is your f? Five minus x over 3x plus 2, right? Now what does the f inverse function tell you to do? You start with, here it is up here, start with 5, subtract from that 2 times what? This thing in parentheses. See, it was the x here. It now becomes all that mess. That becomes 5 minus x over 3x plus 2. Okay, we've done the numerator. The denominator starts with a 3 times all that mess. 5 minus x over 3x plus 2. And then you add 1 to it. All right. Now, how do we simplify that? Looks sort of familiar, doesn't it? Second? Yes, multiply numerator and denominator by 3x plus 2. Every term in there. That's by 3x plus 2. This is by a 3x plus 2. This is by a 3x plus 2. And this is by a 3x plus 2. All right. What does that first part of the numerator give you? 15x. Second? Plus 10 minus, what happens here? Those go away. Can you go on and do that multiplication? Negative 10 plus 2x. Very good. Divided by, and down here the 3x plus 2's go out, and that gives us 15 minus 3x, isn't it? Minus 3x plus 3x plus 2. Okay? Now, what happens to that numerator? Second? Yeah, the minus 10 and plus 10 add to 0, which is 17x over, and here your 3 x's go out, 17, and that's equal to x. Ding, 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 ding. Huh?
Trying to clear out the x, right? At the end of the day.
No, you're solving for y. Okay. Well, no. Well, you're simplifying the expression, and you want those. You want it to wind up just an x, and that's what we got.
You want it to run by itself.
Yeah. Okay. You want it to be an x by itself. Okay. If it doesn't, then that didn't have an inverse. Okay. So yes, we have yes.
So what would be our actual answer?
Your answer is that is the inverse, right?
Okay, that's the actual answer.
Yeah.
I mean, I understand that we're trying to figure out if those go together, but that would be the actual
Yeah.
answer.
It's sort of like when you worked a problem and then you went back to check it and make sure that you had the right answer. That calls a verification. Yeah. All right. That was example 6. There is a checkpoint there, which is a really good thing to look at. We have a couple more minutes, but I don't think we're going to have time to do example 7. So we're going to pick up example 7 next time. So that looks like to me, folks, that the test is going to be on Thursday. Okay? So let me give you a second. Okay. The homework exercises here will be any of the odds 7 through 13. Okay? All those are on calcchat.com. Number 9's on calcview.com. Excuse me. Either 15 or 17 or both. They're both on CalcChat. 15's on CalcView. Do number 19. It's on CalcChat, but not on CalcView. Then do any of the odds 21 to 31. They're all on CalcChat. 23's on CalcView. Then do 33, do 35. Okay? Then do either 37 or 39. All those are on CalcChat. then do either 41 or 43. They're both at Calc Chat. 41's at Calc View. Okay? Do any of the odds 45 to 53. They're all at Calc Chat. 45's at Calc View. Do any of the odds 55 to 69. They're all at Calc Chat. 61's at Calc View. And let's see. We're going to hold off for the rest of those. We'll do those next time. Okay? All right. Any questions?
Will you be giving us a study guide or like study guide or some other?
Okay. Have you turned in your quiz? Okay. And by the way, I wish I had said this before everybody left. I really need those quizzes in, people. Right now I have about, well, maybe a few more than half. But there's quite a few that I don't have. Huh?
Everybody hasn't turned in their quiz?
No, that's correct. And that's why I can't return them to you. I'll let you see them anytime you want to, but I can't return them to you because that'll have the correct answers floating around out there and someone else's eyes may fall on them. So that's going to be your best study guide. And I'll talk about later, at the end of the chapter, I'll give you a few more that you can look at. Okay.
Thank you.
Can we use the websites?
Yeah, those are great things to look at. Now, remember also, and I said this early on, but you may have forgotten. I wish everybody were in here. For your test, remind me to say this next time too. For your test, you can have a formula and equation sheet. So I would say make up your own study guide, write it out on one piece of paper. You can have that in there with you for the test. Okay.